Good afternoon. We're talking about sequences today in Algebra 1, so let's jump into the homework today. Today we're going to be looking at pictures and stories and trying to figure out, what is the sequence doing, what are the numbers involved, and trying to predict the future part of the sequences. So I underlined everything in terms of the directions in different colors, so this one actually has several different parts. For each sequence, let's describe the pattern in words, real basic, and then represent the sequence as a numeric sequence, just the numbers that seem to be involved in the sequence pattern. And also as a table of values, we want to try to get the first 6 in. So I'm going to try to lead you, and hopefully you can finish it out. So the first problem says we have some matchsticks, and basically they're laying these matchsticks in a pattern. And so let's try to break into it. First of all, we have 3 pictures, which I think of it as like first, second, third term. Today we talk about terms as like the specific value of the number that's in the sequence. So for example, our first picture or our first term seems to have 4 matchsticks in it. Okay, so my very first number is 4. So then we kind of look and see, well, how many other matchsticks are involved in the second one? So we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we get in the third picture, and we'll do the same kind of thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so now we kind of start thinking about, well, what will the next picture be? And how many matchsticks would be in the very next picture? So I'm going to try to start analyzing the sequence and trying to think about kind of what happened, what did we have that was given at the beginning, and how did we get to the next one, or do we seem to be adding the same amount, do we seem to be adding a little bit more each time, and so forth. So first thing I'm going to do is I'm going to go back and start analyzing kind of where we started and what they have in common. So these first boxes seem to be the same every single time. Everything is built on that initial 4 matchbox that are laid out in a square. And so now what I want to do is I want to kind of see, well, what happened after that. It seems like this one got 1, 2, 3, 4, 5, 6, 7 added to it. And that is what I see here in terms of how I get from 4 to 11. I'm going to add 7. So then I look at this other one, and all of this is the exact picture as the previous one. And so now it looks like I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm adding 10 that time. And so why am I seem to adding 3 more, and where is it going on in the picture basically? So let's kind of jump in and see kind of what happened. So I've got one that's going to be the same as that initial one there, and that one's the same as this one, and this one's the same as that one, but it looks like this one will really match this matchstick here, and so I have this extra one here to kind of make it a little bit bigger, a rectangle in that term. And so, okay, I'm going up 1, got 1 there, but then it looks like these match, and this one kind of got left out in terms of the one in the middle. And so let's keep moving around. So this one right here is already a part of the other sequence, and so this red one here is the third one that was needed to kind of make the square a little bigger each time. So if I was going to guess, I would think that was going to happen again whenever we go to make this shape the next time and it's even wider. We're going to see that same situation where I'm going to need a few to make it happen, okay? So I'm going to go ahead and say that what's going to happen is the next term is not going to add 10, but it's going to add 13. So I believe the next one will probably have 33, okay? So go ahead and describe to me in words kind of what we did there. Try to represent the sequence all the way to 6 terms. And when we talk about a table of values, all that means is kind of putting the idea into terms and number of sticks. And this is a great way to break down word problems that have to do with sequences. The first time it has 4, and the second time it has 11, and so forth and so forth. So go all the way down until you get to 6. You want to figure out how many would be in that very last pattern of 6 terms. All right, the next one, Hancock Homes, is a popular construction company that builds affordable housing. When the company first started, they sold 1 home the very first month. Then they had 3 homes in the second month, then 9 homes in the third month, and 27 in the fourth. So same idea. I kind of describe this pattern as more multiplication. And I would say that it's more multiplying by 3. So 1 times 3 is 3, and 3 times 3 is 9, and 9 times 3 is 27. So if I was going to kind of break this down, I would say, okay, the first time you get 1, and the second time you get 3, and then that third month you're getting 9, and then 27. So not too bad now that we know that it's multiplying by 3. And so go ahead and tell me what that next number would be. Putting that in a table wouldn't be very hard either. It'd be like 1, 1, 2, 3, 3, 9, 4, 27. And so once you know those next 2, you can kind of complete the table with the next 2 values. Let's go ahead and jump into the third one. I'm going to read it to you, and I want you to do it completely on your own. It says you have a yoga instructor named Violet, and who regularly posts new exercise videos on a website for her clients. 1 week after launching the website, she posted a total of 6 videos. That's the very first time, kind of thinking about making a table as we do it. And then the second week, she had a total of 10. Third week, she had a total of 14. And at the end of the fourth week, she had 18. So we can kind of break that down into weeks here. First, second, third, fourth, 6, 10, 14, 18. And in terms of completing that sequence, go ahead and tell me what it would be all the way to the 6th week. Okay, so let's stretch it a little bit. Robin's opening a restaurant and tells her staff that she's going to go above and beyond to please her customers, especially since it's opening day. And she reasons that if one person is pleased with the restaurant, that person is likely to tell 4 people about it, and then those 4 people will go tell 4 people, and so forth and so forth. So we have 4 different bullet points that we're going to answer. We want to talk about describing the pattern. We also want to figure out, well, how many customers you're going to reach when you're talking about the 5th and the 6th and the 7th telling of this. We want to represent the number of customers reached with a numeric sequence. And then also that last part, figure out which family we think this falls under. So I went ahead and drew a picture to kind of get us going with this. And this is a huge part of where we are with online advertising. I think about Yelp and how big of a supporter that is for local businesses, because they try to get people to go on and do reviews, and then those 4 people see 4 people others' reviews, and then it just blows up exponentially. Okay, so that first person, they go and tell 4 people, but then those 4 people go tell 4 people each, and now you're at 16. And so this is another exponential situation where this time you're multiplying by 4. Okay, first person times 4, 4. Second time, those 4 times 4, another 16. 16 times 4, now you're talking about 64. If I was going to branch out all 4 of those 16 people, if 4 people on each of those 16 stems, that would be 64 total people. Okay, so if I'm going to describe the pattern, again, I'm going to say it's multiplying, and it's multiplying by 4. This is an exponential situation where it's going to blow up rapidly only after just a few tellings. So how many customers are reached after the 5th, 6th, 7th? I want you to figure that out based on the pattern. We kind of figured out that the first time you only have 1 customer, but that first time you tell somebody, you're now at 4. Now you are at 16, 64, and so forth and so forth. And so if we're thinking about the function family, we think about the ones that we had from last week. We had linear, we had quadratic, we had exponential, absolute value, and piecewise. So if we had to think about which of these it would fall under, you can kind of back the tape up a little bit and hear me say that it was under exponential. Okay, you started with 1 person, and that's rapidly going to grow really quickly. And it's because of this multiplication by 4 every time. So I want you to think about, is that discrete? Is that continuous? Don't take my word for the picture here. It was just kind of a general idea of the sketch. So just think about are decimals possible, and we'll kind of go over that in class. The last part's a review. So for each scenario and graph, we're going to do three things. We're going to identify the family. We're going to describe the domain, and we're also going to identify the behavior of the graph as increasing, decreasing, or maybe a combination of the two. So the first one says the city discovers that its population has been tripling. So one thing, population always goes with the similar concept. And when we think about the word tripling, is that more adding, subtracting, multiplying, dividing? Definitely more multiplying. And so we're seeing this graph grow exponentially really quickly. And so if I had to put this in a family, it's definitely exponential. In terms of thinking about the domain has to do with the input or the independent variable. And so time in this case is independent. The population depends on how much time has gone by. And so if we're thinking about this graph, what would you say the domain is? If you're thinking about where it starts, because there's definitely not an arrow on the left, but where it ends, there's definitely an arrow on the right. So how does that, what does that mean for the domain? I want you to answer that question on your own. And then the last part says identify the behavior as increasing, decreasing, or combination. Well, this is definitely increasing forever. Okay. So the last part that I want you to do for this question is go ahead and answer the domain, which I did not do. We'll do that in class tomorrow. Similarly, for each of these other questions, read this problem and think about which function family you'd put it under, describe the domain and range, and then try to tell whether you think the graphical behavior is increasing, decreasing, or a combination. Same thing for this last one, except we're talking about functions. So if we're thinking about functions here, and actually I don't think the directions go with this. Let me move that out of the way. Determine whether each data set represents a function. Remember, if it's a function, each x has only one y. That becomes a lot more useful in programming because you have a lot of machines that take input. You want each button on the machine to only have one command. So let's think about each x value here. Remember that ordered pairs are all x, y points. And so we're looking at all of these and we're looking for any that repeat. So go ahead, tell me if you think that's yes or no based on what I said the definition of a function is. Similarly here, think about the x values and tell me if you think that is a function, yes or no. I hope this is helpful, and we'll go over answers tomorrow in class.